So, in this lecture we are going to get some hands on of Arduino programming, and so this lecture and the next one as well. So, 2 lectures are completely devoted to Arduino programming. So, in the first lecture you are going to get some of the ideas about the basics of Arduino, and in the second one some of the examples about how the programming can be done with Arduino. So, before we proceed further, I would like to remind you a few things, that Arduino is very much popular at present. It is used for different implementations of IoT throughout the world. Arduino devices are very much cheap, they are low resource consuming, and that is why they are very much popular for use in implementation of Internet of Things. So, in the first module we have seen different things, we have understood the concepts of Internet of Things, basic concepts, the overall philosophy of Internet of Things. We have also seen that there are different types of sensors, different types of sensing possible, different types of actuators, the principles behind different types of sensing, different types of actuation. We have seen that there are different types of networks that are possible for use, for adoption, for use in IoT. Different types of communication devices, standards can also be used for communicating in Internet of Things. So, having understood those, how can we use these concepts for building a real Internet of Things, maybe in a smart home scenario at home, to improve some of the daily tasks that we do at home, or in a smart homes smart city scenario, like in a smart hospital, smart smart transportation, connected vehicles and so on. So, for all these we need to take help of different IoT devices, and one of the very popular ones is Arduino. So, Arduino, if we have to use for the building of Internet of Things, you have to buy these, which are very cheap, and then you have to program these, and this is what I am going to teach you in this particular course. So, with me actually I have Mr. Anandaroop Mukherjee, who is going to take over, and Mr. Mukherjee is going to take you through the hands on of Arduino programming, through starting from the basics to the little bit moderately advanced concepts of Arduino programming. So, I would like to show you first how a Arduino device looks like. So, this is the Arduino Uno. So, Arduino has different variants, they all have different differences in specifications and so on. So, this is the Arduino Uno, and this device that has to be programmed. This has to be programmed. As you can see over here, this is very small in size, and it can be very much integrated with these Internet of Things. When you are trying to implement Internet of Things, it can be implemented on top. So, this device actually the different sensors that you have learned in this particular course. So, these different sensors can be fitted to this device, the different actuators can be fitted to this device, and these sensors, the different sensors and the different actuators, after fitting, the data that is received from the sensors, these can be sent through the communication unit in this, which Anandaroop is going to talk about, and how this data can be disseminated and can be sent for further analytics, further storage and so on.
Hello, I am Anandaroop Mukherjee. I am the TA for this course. I will be taking you through the basic features of Arduino in this lecture. So, to start off with, as you already have heard, Arduino has become very popular nowadays. So, first of all, the main reasons is it is an open source programmable board with a built-in microcontroller and a software IDE, and this software IDE will help you change the behavior of the microcontroller according to your needs. So it accepts analog as well as digital signals which can be given as inputs, and it will give outputs which are mainly digital. So no extra hardware is required to load a program into the controller board. So for the people who have worked with 8051 series microcontrollers, 8085 microprocessors, they must have remembered that you needed an extra programmer to actually program the processor board, and there were lots of interfacing ICs, and all those things are not required with the Arduino based systems. So to start off with, there are few basic variations of the Arduino boards. There are Atmega 328 based microcontrollers. They have Atmega 32U4 series microcontrollers. They have Atmega 2560 series microcontrollers, and then there are Atmega 91 SAM 3X80 series microcontrollers. So these are some of the core microcontrollers. As you can see, if you focus on this IC, this Arduino board, so we are using a Uno board to give a demonstration. So this is the IC chip and basically all the other ones are either the voltage converters or interfacing ICs which are required for the input output functions with this Atmega series chip. So basic features of Arduino Uno: they operate at a voltage of 5 volt with a clock speed of 16 megahertz, and they have 14. Normally Arduino Uno has 14 digital input output pins, 6 analog input pins, 6 PWM pins, 1 UART, that is universal asynchronous receiver and transmitter, and the interface is mainly via USB of Atmega 16U2. So the board details are, as you can see from this figure, you have a USB connector to which you connect your Atmega board to your PC. The best thing about this is the interfacing is very easy. You can connect your system Arduino based board to either a Windows based PC or a Macintosh or a Ubuntu or Linux based system. So this is the USB connector. Then you have the power connector to power on the device in standalone mode. Otherwise, if you connect it to a PC, it draws power from the PC itself. And this is the analog reference pin. You have 14 digital pins which can be used as input and output. As you can see, starting from 0 to 13, these are the 14 input output pins, and over here you have 6 analog pins, A0 to A5, which can receive analog inputs, and these are some of the power connectors. You have a 5 volt, 3.3 volt and ground connections and so on. So these are just some of the basic components of the Arduino. Now the Arduino IDE is basically an open source software. The Arduino system itself is an open source system. The hardware specifications are available. You can, in fact, if you have fabrication facilities, you can actually fabricate your own Arduino device. So this Arduino IDE is an open source software that is used to program the Arduino board. So it is based on the variations of C and C++ programming languages, and it can be freely downloaded from the Arduino's official website. So the basic setup is, the power from the board is derived, as you can see, the power from the board is derived from the PC using the USB. So if you're initially, for testing purposes, you will be connecting it to the PC to upload your program, and when you're running it in standalone mode, when your program has been uploaded on this board, you can run it from this power supply input. You plug in a DC adapter of 5 volts and it's going to work fine. Then next you launch the IDE, then select the board type. So let me show you. So over here I have my Arduino IDE. As you can see, so you have some basic functionalities. This is the code verification button, this is the code upload button, then you have the file menu. You can create a new sketch. A sketch is actually the program you write for an Arduino. Then you can open open an existing program, open recent programs, and so on. You even have examples, basic examples provided with the IDE, which can work with various Arduino based boards. Now moving on to this sketch, the most important part is this tool. Whenever you connect your Arduino board, so I've connected my Arduino board to my PC. Now from this tool, these are the available boards you can see. Since I'm using an Arduino Uno, it has been automatically selected, but in case it is not automatically selected, you can choose the appropriate board. Arduino Uno. Now for my Mac, the port is already this USB modem 1421. You can see Arduino Uno has already been selected. So now we are all set. Okay, one more important thing is, over here you can see this button. This is the serial monitor. This is one of the good features of Arduino, that while executing serial programs, you don't need to have an external console or that kind of software. You can just use the inbuilt serial monitor to view the program. So now once the board and the ports have been appropriately selected, as I have told you, you select the board, then the corresponding port in your PC. For Windows based systems, it will be more or less direct. It will show you a COM based port. It may be COM 4, 10, 15, anything. You choose it appropriately. Then I've already shown you this. So your Arduino Sketch, as you remember, the program which is written into the Arduino for the Arduino is called a sketch. So it consists mainly of two parts. One is the setup and one is called the loop. Setup is analogous to for normal main C or C++ based programs. The main function you use, it is analogous to the setup function in Arduino, and as the name suggests, the loop function, it is used for iteratively looping over instances. So it's more or less common. From file, you click on new, it will open a new file, and you can try out various examples and sketches. So we have also covered this one. This is the verify button. So the main feature is, prior to uploading your code, if you have syntax errors or any such logical errors, it will be caught during verification. It will say your compilation has failed. Once you pass this verification check, you can upload your code. So okay, now this we talked about. This is the serial monitor. Whatever data is transmitted through the serial port is printed on the serial monitor. So a sketch structure, as I have told you, it consists of two parts, a setup part and a loop part. The function setup is the point where the Arduino compiler actually starts the code. So it's just like analogous to the main function in C and C++, and various input output variables, pin modes, whether you need to, as you remember, you have 14 digital input output pins. So you have to explicitly tell your system whether you want to use the pin in a read mode or a input mode or a output mode. Then the loop function is used for iteration. So in this example code, you can see we just use a serial port, the inbuilt serial port. So we just write serial.begin 9600. Here 9600 is the baud rate. So you can have various baud rates. We'll come to that. We'll cover that in the consecutive lectures. You can have various baud rates for different systems, but 9600 is more or less the commonly used baud rate for most of the systems. And within void loop, you want to iteratively loop this hello Arduino. So this serial.println, that is, if you write serial.print, it just prints the hello Arduino string. Otherwise, if you write println, ln is actually new line. So it will print hello Arduino in a new line. So prior to this, we'll look at the sample code. So as you can see, in this hello Arduino code, within the word setup, we have written serial.begin 9600, and within void loop, we have just written serial.println hello Arduino. Now, prior to doing anything, we verify the code. As you can see, it is compiling the sketch. If your code compilation is correct, so it's correct. It just shows how much memory it is using and all those. If you are in error, suppose I delete this semicolon. Now again I verify the sketch, it will give you an error. So this is a good practice. Prior to uploading blindly, you just verify your code. Okay, now the code verification is successful. The ports have already been chosen. I upload my code. So it is now compiling the sketch and it is uploading it to the Arduino board. Now the code has been uploaded to the Arduino board. Since the function of this program is to print hello Arduino on the serial port iteratively, we'll open the serial monitor. As you can see, it is printing hello Arduino, right? So it is actually quite fast. We can actually modify it. We'll put up a function called delay. Let's say a delay of 1 second. So this 1000 is actually the delay in milliseconds. We'll put up a delay of 1 second. The code has been verified. We upload it again. Now again we open the serial monitor. Now you can see, now the delay has been increased, so it prints after 1 second. So I hope this was easy. Now let's move on to the next menu. Okay, so like other programs, Arduino also supports various data types. You have void, int, boolean, byte, word, float, array, string object, long, char, unsigned char. It is somewhat similar to your normal C programs. So Arduino has lots and lots of libraries. Since it's an open source platform, collaboratively people and companies and organizations, they upload their own Arduino libraries. So for most of the functions, you'll obviously get easy access to various libraries. So as you already know, the pins can be configured to act as input or output depending on your requirement. So to do this, this function pin mode is used. So you can see the syntax is pin mode, pin, comma mode. So this pin is the number, the pin number, actual pin number on the Arduino board. As you can, if you focus on this board, you'll see various pin numbers are written over here. 1, 2, 3. Since these are the digital pins, it is also written digital. So in the pin mode, against the pin, you just write the number of the pin. So it's that simple. And the mode, you just write input or output. If you want the pins to work in input mode, like you're connecting various sensors to it, which you will acquire sensory inputs, you put the pin in input mode. And if you want to actuate something, maybe a light or LED or a motor, you put the pin in output mode. So various Arduino function libraries, you have digital write, so which writes high or low values to a digital pin. Since you have to remember, this thing mainly works on a binary logic. You either have a high voltage or a low voltage corresponding to 1 or 0. So your digital write, it either writes a high or low value to the pin. Then analog read function, it reads an analog function, analog input from the analog pins. You have 6 analog pins. Then character function, you have various character functions to check whether it is a character or a digit. So you can see the various functions: is digit, is alphanumeric, is X digit, is lower, and various other functions you can use to check whether the input is a character or a number or a alphanumeric combination, and so on. So this next one we have already covered, this delay function. So you'll find it is one of the most versatile and commonly used functions in Arduino. So input is taken in milliseconds. As you recall, we put 1000 for the delay. So 1000 milliseconds converts to 1 second. So next one is, we'll use an Arduino and a normal breadboard to switch on and off a LED. Now we have got a LED, we have got our Arduino board. As you remember, these are just the basics of electronics. So for a LED, the longer terminal is the positive one, whereas the shorter is the ground. So we connect the longer terminal to one port, other to the ground. Across this LED, we connect a 220 ohm resistance in series prior to taking input from the Arduino board. So this is LED blink. So if you concentrate on the setup part, within the setup you see the pin mode selected is 12 and it has been selected as output. So it basically translates to pin 12 will act as output. So we'll connect the LED to pin 12. Whereas in the void loop you can see this digital write. If you recall, digital write either writes high or low values to a particular pin. So digital write 12 high means you are writing a high value to the digital pin, to pin 12, and you give a delay for 1 second, then again you put the pin 12 to low, then again a delay. So this will cause the LED to blink on and off with 1 second delay each. Now if you come back to the processor board, so we have connected the LED and the resistor on the breadboard. From one side of the breadboard we connect a jumper cable to pin 12 on the Arduino, and for the other, since this side was the negative side or the ground, we connected to a ground. So we simply connect this to a ground pin. So again refreshing, we have just created this simple circuit. We verify our board is Arduino Uno, the port is already selected. We verify our code. Now the code has been verified, we upload our code. Just as soon as the code is uploaded, you will see the LED starts blinking with a delay of 1 second. Right? Now for easier checks, you can always use pin 13. Pin 13 is by default, for Arduino Uno at least, is connected to the inbuilt LED. So I mainly check validity of a code based on pin 13. You won't require external interfaces then. So if you focus on the Arduino board, this small LED over here, this is the inbuilt LED or the indicator. Now I uploaded my code. The same function you saw on the external LED is being applied on this code. I have just changed the pin number from 12 to 13. So we have covered these things. We have connected pin 12 and the other side to the ground. We wrote the code and uploaded it. So, okay, this was it. So in the next part, we'll go into more details of Arduino programming. For now, thank you.